So this is what I have done for the game. So the scene cycling has been done, but I mean most of the 90% of the some compromises have been made. Some but it makes the game playable, but like design wise these are like just bad design choices, but to make the game some hacks have been done. But yeah, I mean this is a working game, so you can enjoy 2 levels of it and the game will be ending. So the scene cycling has been done, but like after game over, like you have to like quit it and start it again. So it goes from one level two. So yeah, this is the game starting. So to demo it, some sounds and animations have not been done, but most of the things has been done. Like we have the toggle on and off. So this is the toggle on and off. So this has been demoed, and you can see the collision that cannot go beyond a certain point. And you can see that the missiles it gets impeded, shields implement the missile, and yeah, destruction is happening, and you can see that the shield is also being destroyed. So this is a demo that the shield is working, and if you destroy, you can see that the alien grid is being destroyed. And some sound and animations have not been done, and yeah. Yeah, it's like different bomb patterns are dropping, as you can see, and it does not drop from the bottommost alien, like it's just been randomized, so it can drop from any of the aliens. And as we keep on destroying, the speed it keeps increasing, not significantly, but yeah, it increases. The sound for the alien marching has not been done, like, but for the collisions, all sound has been done. Yeah, so the score updating has been done properly, and level shifting, like instead of respawning, I just created a new scene because like there are like some errors which I am not able, time constraints I'm not able to solve it, and yeah, and so after that it goes to a game over screen. Now I will demo for the game over. Like as this same thing, like I have like 2 levels implemented, and if I collide, like the lives will get reduced. So 1, 2, and winning or losing, it goes to the game over screen. And as I already like displayed, I mean last scene, like if I lose it, I'll just like lose the life for the whole demo. And all the collisions have been implemented. So I mean even the missile to missile collision has been done. So yeah, I'll die and explain. So this is the working demo. There's no problem with it. So yeah, the base game has been done and it works to 100%, but some design pattern choices has been like bad design, like it's not the best design choices, and this is what I have planned for the improvement if it exists. Yeah, game over. So as you can see, the whole I completed the game, but like I had to make like a lot of design choices, and for the because like I had a lot time constraints, and one of the main bad design choices compromise that I had to make was like having a scene, creating a new scene instead of just respawning it. Second is like this game cycling has been done, but after game over, it's just that you have to quit it and start it again. So I mean, like you cannot restart the game like after it's over. So scene cycling has been done, but it's like restarting the game, you have to quit it. Score updation has been done to 100%. Collision has been done 100%. So the visitor collision that has been done everything, and demo has been shown. Toggle bounding boxes demo has been shown. Sound is not being 100% implemented. It's and the animation the it got buggy. So the animation there is no animation, and different types of bombs are being dropped, which has been demoed, and all movement has been demoed. 2 levels, and each level is making progressive and highly faster. Shield has been implemented, and missile firing sound, collision, death effect sound, that has been done. And shield destruction has also been demoed, and that's it for the demo. Like, and that's it for the game. Thank you. So this is where I explain like all the concepts that I've implemented, what I've done, and everything. The video demo I showed in the previous part, and now I'm going to show the code in depth. And each pattern I'll explain in like 10 to 20 seconds. So for the object pooling, we have the manager class, which is right over here. Yeah. In this manager class, like more than one pattern has been used. Like I used both object pooling and template pattern. Here, object pooling, we have two lists: linked list, active and reserve list, and according to the needs of the game, like nodes are being shifted from active list to reserve list and reserve list to active list. So when reserve list gets empty, new nodes are created. Else, nodes from reserve are shifted to active, and that active list is being used throughout the game. This is the example of object pooling, and also we now have template pattern. In template pattern, it's especially used for the derived create node, derived compare node, and derived compare keys. These three uses the template patterns. These codes are implemented in a derived class, but they are being used in the base class itself. As you can see here, the derived create node, it has been described as an abstract method, but it's being used in the base class itself. The the compiler uses polymorphism for it to go to the correct create node and for it to be created. So the next concept I'm going to talk about is the factory method, and for factory method I created for the alien factory and also the sprite factory. Oh, I'm sorry, shield factory. You can see like we use a switch type which is like efficient. Like this can also be done using the if else. Like we just pass in the parameters and a new game object is of the particular type is being created, and then it is being added to the sprite batch. All the collisions has been implemented for the for collisions to be done. We use the observer pattern so that when collision is detected, the observer is set off, and according to the uh, in observer there is a notify pattern, and this pattern is what contains the code that must be done when collision occurs. So this is for the observer pattern. We have like a lot of different types of observer, and then we have the composite pattern. Composite pattern we have is actually a derived class from the base class of component. There are two types of component, basically a composite and a leaf. The composite is the for the example, the alien grid and the alien column. So the composite and all the aliens which are in the game is the leaf. So we use this composite pattern to like affect a change for all the things in the composite grid. So if you like give a move command to the whole grid, the every element in the composite it gets affected by the move command. So like this is for the composite, and then we have the iterators. This iterator is used to like iterate through a data structure. Like this is for iterating through a composite, and we also have another iterator which is used to iterate through the linked list which you are using in the game. Another thing which is there is the scene context. This is like for the scene changing, so we have like different scenes, and this makes sure that after certain conditions are met, the scene is changed. We have the select screen, the playing screen, and the screen over screen. Yeah, I mean I had to make some little bit of compromises. Like I am not like able to like respawn the whole grid, so I instead like created a new level. So just had to hack away. That's one of the compromises I had to make. And another one thing that has been done is that once the game is over, we have to quit for the new game to begin. So that's one of the few compromises. And Lastly, like few of the animations, like it got crashed, and the sound, like on few sound effects on I'm not able to implement properly. So that's it. Like the whole game works, but some design choices has design compromise has been made so for the game to work. So that is that. So it can shift from one scene to another, and when it's game over, like we have to quit it. So that's, I mean, that's one of the few things that I plan to improve, but due to time constraints and time constraints, I was had to like make a lot of compromises. So another thing we have is the command pattern. This is what we use for the bomb dropping, the bomb, the alien movement, the sound enter. The main thing is that here the timer event manager, and this is mainly responsible for the commands being executed. Here we have this process method, and if you go to the process method, we have this execute command. And in this execute command, we write the code for which has to be implemented when a command has to be executed, and the timer event manager is responsible for this to happen. Yeah. Looking at another concept, we have the Sprite proxies. Sprite proxies are mainly used in the game objects. So I'll go to the game objects now. Here you can see that like the game objects points to Sprite proxy, and if I go to the Sprite proxy manager and .add, we can see that new Sprite proxy is being created, added to the list, and then that Sprite proxy is being returned. So what is Sprite proxies? Definition, everything has been like detailedly explained in the design documents, but it basically is just like a copy of the game object with a pointer to the original game object. As you can see here, that we have the sprite which points to the original, and every update values from this are pushed to the real value. Like as you can see, we are pushing the values from this to the real one. So another interesting concept that I have to look at is the strategy pattern. Strategy pattern is not interesting in the sense that compared to state pattern, it's very less flexible. The only place where I'm using strategy is for like doing different design, bomb drops. So we have different bomb drops here, and all this uses strategy pattern for it to work. This is just like an unflexible method of state pattern. So anywhere it's much better that we use a strategy. It's I mean a state rather than a strategy, because like strategy is just useless. Like there's not much use. So, and the main concept, the singletons has been extensively used in this whole concept. Like this is one of the main things, and one of my favorite design patterns actually. A singleton ensures that only one instance of a class is created. The full details of the singleton has been like mentioned in the design documents, but to explain it rough and quick, we just make sure that the whole manager class, only one instance of manager is created, and this manager constructor is only called once. Oh, sorry, I am in the wrong one. Yeah, yeah. Here, as you can see, it checks like this has the instance of the objects, instance of the class stored in it, and if this is equal to null, it means that it has never been created. And once it is, an constructor is called and is created. Once it's created, this is a static variables, and it stores it till the destructor is called. So till the destructor is called, everything related to this Sprite batch manager, which I'm right now, like this, we do everything related to the Sprite batch manager using this instance. And this instance is a private static method. So to call that instance, we create a public static method. See, it's a private static, and to call it, we are using a priv get method, which is a for here it's a private, but technically this will be most of the time it will be a public, but it is a static method. Like I'll show some other example. Static, public static. Oh, okay. Okay, my bad. It's actually a private statics. Oh, I mean not. Yeah, I mean because like only thing which are using this method is inside this whole class. Like the remove is calling it like so. All that can be are made as a public static. So that's why it's a private static. So that's it for my demo, and I hope this is sufficient. Thank you.